You're watching a skilled player play Super Mario World, but this player is not human. It's a computer program SethBling wrote called Mario. I watched this video back in 2015 when I was 14 years old. That was before I knew what programming even is. And back then when I watched the video, I was amazed. But now, 11 years later, I have more freedom, I have more options. On top of just being amazed, I can also do what he did, because I want to be the person a younger me would admire. Let's do it. I began with this amazing free book where I read about history of neuroevolution, various algorithms, evolving organic structures and tables. That'll be a sick video idea, evolving tables. We could make table 2 because we haven't progressed for like millennia here. Anyway, I also read here about neuroevolution of augmenting topologies, the algorithm we're building today. The general idea here is that instead of training neural networks, how it's typically done in machine learning, we evolve them, which is a nice way, a family-friendly way to say that we create a population and then eliminate the low performers. I'm not gonna sugarcoat it. And of course we also combine genes from two parents and then introduce mutations to create offspring, because the idea behind evolutionary methods is to mimic natural evolution. So I studied the original paper, I studied reference solutions, and then programmed the algorithm myself and ran lots of experiments. And by the way, the link to my code is in the description if you're curious about all the details. Now, just to be sure, let's test my code on a simple environment like Lunar lander. Not bad. Now how about we visualize it? That's a wrong video. This one. That was a very optimistic point of time to be in. It looked like it's almost over, like everything works. Like all that's left is to run the algorithm, the working algorithm, on Super Mario World, and that's the project. One can dream. Because life is not so easy. And Super Mario World is not so easy. I just cut my headphones. Doesn't matter. SethBling used BizHawk emulator that supports scripting in a programming language called Lua. So he wrote his whole algorithm in Lua. By reading game's memory, he created a 13 by 13 grid around Mario with values -1 for enemies, 0 for air, and 1 for solid blocks. That was used as an input to the neural network. Then he implemented the neat algorithm that evolves synapses and hidden neurons that produce an output, where a positive output is associated with a pressed button. So the biggest magic here lies in this input simplification. He read game's memory live and translated it into this very informative grid. And I want to replicate what he did, but there are multiple problems with it. First, I don't want to script in Lua. I mean, with all respect, but what the heck is even Lua? That's way too niche. I want to use my familiar tools in Python, so I had to use stable retro, a community maintained fork of RetroGym that supports Super Mario World. But using RetroGym came with many challenges that I had to discover on my own on this eye-opening journey of sorts. I tried using the same memory addresses as SethBling, but it didn't work. I prompted LLMs for hours and hours and none of them knew how to do it. The enemies were recognized fine, but not the platforms, especially not the ones in the background. With a lot of debugging, one thing was sure: the memory layout is just different. With more debugging, I figured out that SethBling used game memory modified with Lunar magic, a Super Mario World hacking tool. Alright, we're getting somewhere. So I modified the memory, put it in stable retro, and got this on the left. This is our game frame. And it's actually not bad. And I'm only half joking. Because can you imagine not encountering obstacles? We wouldn't know how to handle them. This is literally what the name inexperienced me comes from. Because gifted kids often fall into the trap of things being easy. So as soon as they face some obstacles, as soon as they struggle, they give up because it doesn't fit their talented kid personality. And talent alone goes nowhere. That's why we have to struggle and be fine with it. As a training, as a treat, as a, as a reward for good behavior. Nah, okay, but when I struggle with something, I'm not stupid. I'm just inexperienced. I'll try stuff, I'll get experience, and then crush the problem. I'm already super experienced in getting experience, so there's no stopping me. Alright, current approach is a dead end. We need another route. From my analysis, we have 3 good options, and you can see me locking in because we're getting serious at this point. Option 1. Use BizHawk emulator. Take SethBling's Lua script, send the grid to Python, and train just like him. Super sketchy, super slow to train, super high probability of unexpected problems. On top of that, the SethBling's approach is not even that ideal. Like, you can see it mark this invisible block as an enemy that spawns a power-up mushroom that is also marked as an enemy. Reverse engineering the memory sounds like spaghetti of if-else statements and exceptions and checking flags and who knows what else. So we have option 2. Do what David Ha and Eugen Schmidhuber did in an amazing paper, World Models, where they trained a variational autoencoder to compress the observation, then used a recurrent neural network to combine multiple observations to form a world model of super compressed data that is fed into an evolutionary algorithm. This sounds like I'd have to rebuild my whole training pipeline, and also it strays a lot from what we wanted to achieve. It kind of sounds like an amazing idea for another project. Option 3 now strikes the perfect balance of effort to effect. It's using the observation from RetroGym as is and compressing it only through simple transformations like downscale and crop. I wasn't sure if the algorithm would handle such complex observation without a world model, but it was worth giving a try. And it worked. After 2 weeks of experiments, but listen, a win is a win. I tried using simple downscaled grayscale observation, but you couldn't even distinguish enemies from background, so that was terrible. Next best idea was using the red channel because enemies are usually red. But that was a terrible pick because somehow the green background has a lot of red in it. Like, what? Alright, green channel turned out to be best, so I stuck with it. Then I cropped it, downscaled it further, discovered bugs that made me surprised that any of this worked previously. And after all this, I had 2 runs that after 16 hours of training ended just before the finish line and didn't improve further. My first reaction was, so unlucky. What are the chances for it to happen twice in a row? But then I realized, my goodness, my reward function gave rewards for going to the right and then constant time penalty to pressure the population to get there as fast as possible. But when you beat the level, you stop going to the right, but time still passes. So you got the best performance by going to the very end of the level as fast as possible and then dying before finishing the level. There's nobody really to be angry at other than myself. But I fixed it and we got this.
I just came back home from work, starting my weekend, and look at this. This is sick. Boom, 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 and win. Oh my goodness, such a relief.
Before we begin, quick explanation. We have generation number, fitness, input, bias neuron, so additional input that is always 1, synapses will be here, and outputs. We will be looking at only the best organisms from chosen generations. This is how it begins, with no synapses. But already in the first generation, we have an amazing progress of going to the right. Here we have our first sprinter. And now we have our first jumper. He jumped once? Oh, come on. This is an actual jumper. He jumps too much. And they got stuck here for a while, but we're going places. This is the beginning of what I call the panic crouch. Ooh, a new route? Nice! Oh, oh what? What is this panic strat? We're going places, but now we're also getting stuck on this pipe. And what is funny and interesting is how it kind of evolved to be stuck on the pipe, to wait for the mushroom, and then have a full breakdown. First victory, hell yeah. But now let's see the whole run of the final victory, the best victory. Honestly, not bad. I kind of feel like I need to work on my vocabulary. That was delightful and gratifying. Alright, that's a good word. This is a plot of a top score for each generation, which nicely shows how suddenly evolution works. It's a lot of tiny, tiny improvements and then suddenly a big step up where we have a breakthrough. It's almost like a staircase, except the end because I gave them a generous reward for winning. It's like a central bank that can always print more money. I can give them as much reward as my heart desires. All it took was not just optimizing the observation, the reward function, the algorithm itself, but also tweaking the parameters to explore a little bit more, or maybe a little bit less, or have fewer species, or more species, or stronger mutations, but less frequent mutations, but maybe weak mutations and something else. It's just like so much work because there's no correct way to do it. There are wrong ways to do it, but there is no correct way. You just have to try stuff until it works. Maybe you noticed that my solutions have a very simple architecture with barely any intermediate neurons, because it's exactly how I programmed it. Since doing it the standard way, the networks grew and grew to incredible sizes by default, but I wanted to have a nice and clean solution. But I thought it's also fun to watch this complexity, especially the oscillations here and the complete chaos and the internal feedback loops. It's like I imagine an overthinker's brain just like dude cannot catch a break. There are so many ways to tweak the parameters. And that's the thing, that despite its reputation and despite being super interesting, NEAT isn't that popular, partially because of how hard is it to make work, especially when we have better algorithms now. That's why it would be nice to create something better. My ambition is much greater than mere replication if I ever got to work on this field more. The dream is to implement some form of meta learning, which is learning to learn or evolving to evolve. So we would have all the tunable parameters that are evolving with the organisms for the creativity and complexity to emerge by itself. And so we don't have to manually tweak the parameters all the time. And we would have liberal species that pushes the frontier and mutates a lot, but are kind of sometimes too far going, and the conservatives that barely mutate and stick to their old ways and stuff like this. And we can engage in a political discourse online. Okay, maybe my super idea was not so super, but you know what I mean. I don't want to micromanage my creations. I want to set the rules, create a universe, and just see what happens. But it's just a teaser for now, an idea, because I have no idea what I'll be working on next. I'm not here to master just the neuroevolution or large language models or image generation. I'm here to master machine learning. So eventually I have to learn everything. So I'm maximizing diversity for now to gain the perspectives. And maybe one day I will commit to a long-term project, but this will have to wait. But if you also want to master machine learning, you're invited to watch my other videos. But for now, thanks for watching and I'll see you around.